So our controller is all ready to go. All I have to do is press this start button and the drive's going to start up. Okay, so a couple of things here. First, check out this fancy graph that I made. It's called a trend plot. It shows two lines. One is the set point, that's in blue, and the other is the feedback, that's green. If I adjust my set point, the blue line moves. Notice the response of the green line. So right now we're sitting at about 12 inches. The number in N70 is 15,000. That's our set point. Let's see if I can zoom in on that. N70 is our set point. It can range anywhere from 0 to 32,767. I'll just swing that from one end to the other. There, it's all the way down to 0. And here we can go all the way up to 32,767. So now I'm telling it to go to full, which is 24 inches. Let's see if it gets there. Well, it's sitting at 24 right now. Have you noticed that the drive is not just on-off, but as it approaches the set point, as the level approaches the set point, throttles back. I'll change the set point again. I'll go to about half. So that should be 12 inches or so. Half of 32,000 is 16,000. We're currently just about 16,000. The tank's draining, the pump is running. The frequency of the pump, it's sitting down at 10 hertz right now. Barely turning. I think that might be because we have a minimum frequency installed. Shouldn't be there. I'm going to take that out. Minimum frequency. Okay. Come on, there we go, P34. Yeah, it's set to 10. I'm gonna let it go all the way down to 0. Okay, and I'm gonna start it again. Oh, well, let's let it keep emptying out. I've got this valve relatively closed. I'm just gonna open that a bit, speed up our response time. You can almost see the frequency. Here, we'll do it like that. We'll leave our set point set halfway. Trying to get everything in this one view. So our tank's almost empty. I'm gonna go and press the start button on the drive. Right now, I want you to notice that the error is maximum. The set point is 50%, the feedback is 0%, so we have maximum error. Maximum error results in maximum output. The pump is driving the level back towards the set point. It's getting closer and closer. We're at 120 hertz. Listen to the motor. There she slows down. The frequency is down to 50, 30, 36, 44. We're draining right now. At the same time, we're filling, and those two numbers, the fill and the drain, have to be the same. If they're the same, the level's going to stay the same. And right now, the level's sitting right on 12 inches. Wow, that was lucky. Notice that the green line and the blue line are not the same. The greens come to a steady state, but it's different than the blue line. The blue line's where we want to be, the green line's where we are. You might think, oh, just raise the set point a little bit. It may work for that particular set of conditions, but it won't work for all of them. There's a better way. Stay tuned. I'll give you a hint, it's a PI controller. I'm going to open the valve a little more. I want you to listen to the motor. The first thing to happen when that valve opened a little more was that the level dropped. We're draining more. As the level dropped, the error increased. Set point minus feedback is the error. So as the error increased, the motor responded by increasing. The output increased, causing that to happen. If I close it all the way, motor slowing down as the level increases. Here it's almost to our set point, still doesn't even make it. There's some water draining back through the pump, so it doesn't fully get there. It doesn't get there, and that causes this thing called the gap, and that's one of the disadvantages of a proportional controller. The gap's got to be there. It's always going to be there. This is a P only controller, a P controller, proportional controller. Does a pretty good job, but it could be better. This is the first component in a full-blown PID controller. I want you to think about what's going to happen if I disconnect the feedback. If somebody cuts the feedback wire. Here's the feedback coming into input 0 from the transmitter. Say if somebody cut that wire, what's going to happen? Can you predict it? Do you want me to show you? Looking for my screwdriver. All right, here we go. I'm going to open that circuit. I'm not going to cut the wire. I'll just pop that little circuit open. Ready? Oh, Nelly, we're filling fast. I better get that back in there. Come on, transmitter, boot up. Boot up, boot up, boot up. Oh, there we go. Finally booted up and reported that the thing was full. Heck, almost over full. If only there was a way to figure out if that loop was open or not. So I've opened the valve almost all the way. Still no pumping action. As soon as the green gets below the blue, boom, we have error. So we get an output, so we get a voltage, so we get the pump spinning, so we get water coming back into the tank. And it's going to come to some steady state. Our frequency is staying at around 65. Our level staying just under 12 inches. Look at how solid that is. It's actually 11.5 inches. Staying right there. Wow.